Today's lesson is about compound interest. I just want you to watch this short Futurama video about the power of compound interest.
Do we have enough money to pay Bender's fine?
78, 79, 79.50. Crud. We're 50 cents short.
I'd love to chip in, but Bender stole my wallet.
Hey, that's my old bank. Maybe my account's still open.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $4.3 billion.
That's kind of interesting to see how much money he had accumulated. Of course, we're not all going to live to be 1,000 years old, but you can see how a small amount of money can grow to a large amount, and that's due to compound interest. What is compound interest? So compound interest is when you receive interest on an amount that you invest. That interest gets added on to the amount of money that you started with, so that the next time interest is calculated, it's calculated on that new amount. That process will keep repeating until you decide to take your money out, or if you borrow money, until you pay it off. So unfortunately, the same kind of situation occurs when you borrow money, but because you're paying it off, or making payments on it, you do eventually pay it off, but you are paying interest on interest. And we'll look at that scenario a little bit more when we get into credit cards and borrowing money. So the formula that you're going to need, it does look confusing, but we are going to use an online calculator, and I'll show you how to do it, and it'll make things a lot easier. But I just wanted to show you what the formula looks like and the important parts of it. P is still your principal. That we looked at that with simple interest, and that's the amount of money that you invest or borrow. The 1 is a part of the formula. I think, not too sure if I showed you guys, but when you're calculating, say, taxes on something, you can take the price of the item and multiply it by 1.13, and that ends up adding the taxes onto the amount, so you just see the amount that you have to pay for. So that's what that 1 does, is it just adds the interest on for you. R is your interest rate, so that will be a percent. N will be the compounds, and we're going to look at that just as soon as I'm done this bit here. T will be your time. To calculate interest, now up here when you're finding A, which is the total amount of money you will have, that will always be your principal and the interest included together. So if you want to find just the interest portion, you would take your amount of money and subtract your principal. Now let's look at the compounds. The compounds is how frequent interest is paid to you. If it's paid to you annually, that's once a year. So the interest rate would have to get divided by 1, and your years would get multiplied by 1. If interest is compounded semi-annually, that means you're going to get interest twice a year. Sometimes you might see half yearly, which is what you're going to see in the online formula. So back here, coming back to this here, you're going to take your interest rate, your annual rate, and divide it by 2, because it needs to get broken down to twice a year. And your time would be multiplied by 2, because you're going to get interest twice a year for however many years. Let's take, for example, you have 6% interest. If it's compounded semi-annually, that 6% is going to get paid, or needs to get broken down so that it gets paid twice a year. That means you're going to get 6% divided by 2, which is 3. You would get 3% paid to you twice a year. Monthly, there's 12 months in a year, so your rate needs to get divided by 12. Years would be times 12. Quarterly is 4 times a year, so you would divide your rate by 4, your time by 4. Daily is 365. So the rate would get divided by that and time would get multiplied by 365. You don't need to worry about doing this bit. With the online calculator, it does it for you, so it's amazing. So let's go back and look at what happens to Philip's 93 cents. He invested at 2.25, which is 2.25% for 1,000 years. Now, because I've said that word compounded, we have to use this formula here in white. So let's identify the key things that he needs. His principal is 93 cents. His interest rate is 2.25%. His time is 1,000 years, so T is 1,000, and it is compounded annually. Those are the key things that you need to use for the online calculator. So let's go there, and I'm going to show you how to do it. So make sure, scroll down, make sure it says basic calculator. The principal, we're going to put in 93 cents. The interest rate was 2.25, and the time was 1,000 years. Now notice down here it says the compounds. In this case, it's annually, which means yearly. If you click it, you can see all the different options, and we'll look at that with another example. Click this blue button here, and we're going to find out how much money he's going to have at the end of 1,000 years. The neat thing about this calculator is it does all the steps for you. So see here, it divided the interest rate by 1. This little dot means multiplication. It multiplied its compounded annually, 1 with 1,000. And then it just worked out these numbers here for you. So 1.0225. This little number, the 1,000, is an exponent. So it's to the power of 1,000. So you can see he has over $4 billion. And the interest that he earned is going to be the 4 billion and change minus the 93 cents. And I'll show you that on the next page. Coming back to our slide. All I did was copy the amounts that was on the online calculator. Oops, sorry. And you can see the amount of money that he has, and then the interest down in the bottom left-hand corner. So that's a lot of money. I just want to show you what that looks like graphically. Now, I only went up as far as 300 years because it was 1,000 is really far to go. But you can see where he starts off with very little money, then all of a sudden it starts to grow, and it grows very, very quickly. So that's what happens with compound interest. The longer you invest your money for, the more growth you're going to see. So that's something to keep in mind. If any of you can afford it right now, and I know now is really a tough time, but if you can afford, my good advice to you is to take $25 every paycheck and invest it into some kind of an investment where you get compound interest. It could be an RRSP. It could be a tax-free savings account where you invest money, and you can get some compound interest on that if you play around with the investments. Go speak to somebody at the bank if you can. I'm not too sure if they're open, but maybe when things settle down, and start doing that, because that money will grow very quickly for you. You borrow $18,000 to purchase a vehicle. The bank offers you an interest rate of 9% compounded monthly for 4 years. Determine the amount you must pay back. So let's identify our key things again. Our principal is $18,000. The interest rate, let's do time. The time is 4 years. Our interest rate is 9%, and it is compounded monthly. So those are the key things that we need. Now let's go to our online calculator again and go down. Our principal, we said, was $18,000. Our interest rate was 9%. And it was 4 years. Now our compounds we're going to change to monthly. So this is a scenario where you could end up, this is a very common scenario for buying a vehicle and the interest that you have to pay. So the $18,000, so you can notice here, it's compounded monthly, so we divided the rate by 12 and we multiplied the years by 12. Working out these numbers here, you end up having to pay back $25,765 on that $18,000 you borrowed. That's quite a bit of money. The reason it's so much is because the interest rate was fairly high. You need to, if you can, get a lower interest rate. So it's worth shopping around. The interest that you're going to end up paying, I'm going to take that $18,000 and subtract it from the $25,765. And the amount of interest that you have to pay is $7,765. That is a lot of interest. So something to think about. The lower your rate, the less interest you will pay. Also, if you lower your time, your interest would be lower as well. So going back to our slide, I'm just copying the amounts from the table. Now, if you do borrow money for a vehicle, you're not going to pay at the end of 4 years that $25,000. That's too much to pay at one time. So what the bank will do for you, or the car dealership, is break that $25,000 down for you monthly. So you are paying every month for 4 years. That means you are making 48 payments, because 12 times 4 is 48. So we're going to divide that 25,765.30 by 48, and that means your monthly payment will be $536.78, which is a little bit more manageable. And then when the 4 years are up, you'll have paid for your vehicle and you'll be done with it.